Today, we will solve problem 18 from the 2025 AMC 10A. First, we should see what the problem states. What is the harmonic mean of all real roots of the 4d50th degree polynomial kx squared minus 4x minus 3, where k ranges from 1 to 2025? So basically, this polynomial will equal to x squared minus 4x minus 3 times 2x squared minus 4x minus 3 times 3x squared minus 4x minus 3 all the way to 2025 x squared minus 4x minus 3. So the difference between each of these quadratic polynomials is the coefficient of x squared, which increases from 1 to 2 all the way to 2025. And now, first of all, we know that the scale of the problem, or 4050th degree polynomial, well, in the AMC 10, this is actually a psychological tactic. It's designed to induce cognitive overload and panic. However, we should not be intimidated by this huge number. We will not be finding 40-50 individual roots. That is the path of brute force, the path of failure. Our path is one of efficiency and precision, so we need to deconstruct the system. Phase 1 is to deconstruct the objective. The first step is to translate the objective into a mathematical formula. The harmonic mean hm of a collection of n numbers, which we call Ri, is defined as n divided by the sum of the reciprocal of the numbers. So, the formula in general would be hm equals to n divided by the summation or sigma of 1 divided by Ri. So it's n numbers divided by the sum of the reciprocals of each number. So this formula reveals our two primary targets. N is the total number of the real roots, and summation 1 divided by Ri is the sum of the reciprocals of all real roots. So the problem is now reduced to finding these two values. Now, phase 2 is to deconstruct the polynomial. Let's analyze the polynomial p of x. And we know that p of x here, we can set that as equal to this long product. So p of x will equal to kx squared minus 4x minus 3, k ranges from 1 to 2025. The roots of p of x are simply the collection of all roots of each individual quadratic factor. So the problem is not one massive polynomial, but 2025 small manageable ones, like x squared minus 4x minus 3. So we can define a general factor as q. We can let q of x equal to kx squared minus 4x minus 3. For each value of k from 1 to 2025, this quadratic has two roots. Let's call them ak as alpha k and beta k. Our goal is to find the sum of the reciprocal of all these roots. This means that we want to calculate the sum of 1 divided by alpha k plus 1 divided by the sum of beta k for every k from 1 to 2025. So now, phase 3, we have to apply Vieta's formulas. To find the sum of reciprocals without finding the roots themselves, we deploy the primary tool for this task, Vieta's formula. For any quadratic function, ax squared plus bx plus c. The sum of the roots is negative b over a, and the product of the roots is c over a. And we can apply this to our generic factor q of x equals to kx squared minus 4x minus 3. So here we'll have the sum will equal to the negative of negative 4 over k. So the negative signs cancel out, leaving us with 4 over k. And then the product of the roots would be c over a, which is in this case negative 3 over k. And now we can analyze the expression for the sum of the reciprocals for the single factor, 1 over alpha k plus 1 over beta k. To combine these, we can find a common denominator. So this will equal to the common denominator is alpha k times beta k. And then the numerator is beta k plus alpha k. And now this is simply the sum of the roots divided by the product of the roots. So now we can substitute the values from Rita's formulas. So this will become 4 over k divided by negative 3 over k. The k variable cancels out. So this will leave us with negative 4 over 3. And this is a critical insight that dismantles the entire problem. For every single one of the 2025 quadratic factors, regardless of the value of k, the sum of the reciprocals of its roots is constant, negative 4 over 3. So the complexity was affect k. And now the final phase is the verification of the real roots constraint. We must now address the constraint that we only consider real roots. For a quadratic ax squared plus bx plus c, the roots are real if discriminant is going to be greater than or equal to 0. So we can say that when delta for discriminant equals to b squared minus 4ac greater than or equal to 0. And now let's calculate the discriminant for our general factor kx squared minus 4x minus 3. So we have the delta will equal to b squared, which is negative 4 squared minus 4 times k times negative 3 equals to 16 plus 2k. The problem states k runs from 1 to 2025. Since k is always a positive integer, the expression 16 plus 12k will always be positive. So this is greater than 0. Therefore, the discriminant is always positive. This proves that for every factor, both roots are real and distinct. Our first target n is the total number of roots. So we have n equals to 2 times 2025, which is 4050. Phase 6 is going to become the final assembly and calculation. We have acquired our first two target values, n equals to 4050, and the total sum of reciprocals is the sum for each of 2025 factors. So we have the summation of 1 over Ri would equal to 2025 times negative 4 over 3. So the harmonic mean will equal to, as shown in the formula, n divided by summation 1 over Ri. So this will become 4050 divided by 2050 times negative 4 over 3. So then, 2025 2025 times 2 is 450. So this becomes 2 over negative 4 over 3, which becomes 2 times negative 3 over 4 equals to negative 3 over 2. And that is the answer to this problem.